Hi, are you or a loved one frequently pestered by bug bites? Well, we have a cute and cuddly solution for you, Microbats. Microbats are small bats that use echolocation to hunt a variety of insects like mosquitoes, moths, and flies. These insectivores eat around half their body weight every single night. And don't worry, out of the 24 different species found in northern Queensland, none of them want your blood.
From the mammal fauna, here in the Wet Tropics, the microbats make up about 20%. And it is very surprising to see that hardly any research has been done. We need to know a little bit more about bats because they play an amazing role in the ecosystems we have here by controlling the insects.
These highly social critters are quite vocal during the night. Not only do they use their calls for hunting, but also for communicating with other bats. Each microbat call is species unique, meaning their calls are at different frequencies and last for different lengths of time. Recording these bat calls is a great way to identify them because it's a non-invasive method to research microbat presence and habitat use.
Normally, bats roost in caves or tree hollows, but because of habitat destruction, they are pushed into using human structures like bridges. We can utilize their calls to investigate which microbat species are using bridges for roosting. We conducted our research at 4 bridges along Boar Pocket Road in the Atherton Tablelands. Located at
Thomas Creek,
Severn Creek,
Patterson Creek, Swamp Creek.
Each bridge has a unique configuration which may be more appealing to some species compared to others. For example, the Thomas Creek Bridge has a fairly small underpass clearance with stagnant water. The Severn Creek Bridge underpass is also quite small and dark, and the water moves slowly. Conversely, the Patterson Creek Bridge underpass is much larger and louder due to the cascading falling water. The Swamp Creek Bridge underpass is similar with a large underpass and moving water.
Microbats that are able to use human structures for roosting are better adapted and less vulnerable to landscape degradation and climate change compared to species that are unable to roost in these structures. By identifying which microbat species occupy these structures, we can better inform future environmental management and microbat conservation strategies.
We hypothesize that the multiple species of microbats coexist under the same bridges. They coexist by sharing resources using niche partitioning.
To investigate which microbat species roost under each bridge, we used both passive and active acoustic detection techniques. For passive bat detection, we set out Anabat Swift detectors for 2 nights at a time. We placed the detectors under the bridges or right outside facing the opening. We predicted that bat call detectors underneath and around these bridges would be likely to record bat calls, since microbats often call while coming and going from their roosts.
For active bat detection, we used an echometer bat detector connected to a phone to record calls. Because microbats are most active at dusk, we recorded for around an hour starting at roughly 6:30 p.m. 3 times at each of the 4 bridges.
These recorded calls from active and passive bat detection are converted into images of ultrasonic audio called sonograms.
We entered sonograms labeled as BAT and Unsure into Kaleidoscope Pro's cluster analysis feature to categorize and discern possible microbat prevalence in the area.
One bridge was particularly fascinating. Here at Patterson Creek Bridge, we were lucky enough to photograph a very interesting species of microbat called Myotis macropus, commonly known as the large-footed Myotis. These microbats are the only microbats of Australia that specialize in fishing.
The running water from Patterson Creek is an ideal feeding area for these fishermen. But despite this microbat's ability to adapt, they are still considered vulnerable or threatened in some areas because of loss of habitat, water pollution, and destruction of roosting sites. After sorting our wave files, we found the following total number of bat and unsure calls for each creek. Swamp had a total of 2,184, Patterson had 8,574, Thomas had 1,794, and Severn had 7,773. According to these counts, it appears that Patterson Creek has a lot of bat activity and likely more activity than the rest of the creek crossings. To identify how many types of calls we found, we placed all calls per bridge into a statistical analysis method that places similar calls into groups called clusters. For Thomas Creek, we found that this produced 5 distinct clusters of unique call types. This means that we likely have more than one bat species residing at this creek crossing. However, further analysis comparing cluster wave files to reference files for this species in this area is needed to confirm if there is more than one species present, as even within one species, bats can have a variety of call types, including communication, foraging, and navigation calls.
In addition to our findings, further research needs to be conducted in order to draw strong conclusions to informed conservation initiatives. Potential future research projects could explore a variety of important questions and concepts such as competition between microbat species, type of human-made structure utilized by the bats, vegetation types near bat roosts, or how water plays a role in where the bats reside because their roosting habits are often influenced by water flow or quality. Future surveys could also explore the relationship between artificial roosting frequency and natural habitat fragmentation frequency. Overall, further research is necessary to support and maintain microbat populations because their presence is critical to the wet tropics of North Queensland. We acknowledge the Delgaburri Yidinji and Njanji peoples, whose acts of connection, stewardship, and reciprocity have contributed to the health of this land and the balance of its ecosystems for generations. We pay our respects to elders past, present, and emerging.